Okay, so welcome to another problem solving session, and today we'll be discussing the very unique IMO 2020. The first problem, obviously, which is the problem one. It was geometry, and let's look at it and solve it together. Okay, so there's a question. So consider the convex collateral ABCD. So a collateral is convex if it's if it doesn't have a reflex angle. So this is not a convex collateral. Okay. So the point P is in the interior of ABCD, and the following ratio equalities hold. So angle PAD to angle PBA to angle DPA is 1:2:3, and angle CBP to angle BAP to angle BPC is also 1:2:3. So we call this set of angles alpha. So this one will be 2 alpha, and this will be 3 alpha. And we call this, beta. So this will be 2 beta, and this will be 3 beta. Okay. So angle CBP. So this will be alpha, and this will be 2 alpha, and this will be 3 alpha, and this will be 2 beta, this will be beta, and this will be 3 beta. Okay. So now we bring in some points. So let's call this point N, and let's call this point M. Okay. So how are points M and N defined? So I'll just write it here. So point M is the intersection of the circle ABP with the line AD. That's as apart from A, obviously. And point N is, also the intersection of the circle ABP and the line BC. Okay. So now what can we get from here? So since N and M lie on the circle, so we'll have like a cyclic pentagon already. So what can we do here? So now we have that this angle here is alpha. So it means this angle here is going to be alpha. Okay. And since this was 2 alpha, this will now be alpha. So indeed, AN is the angle bisector of angle ADP. Sorry, of angle PAB. Yeah, so sorry for that mistake. And in similar fashion, we can quickly get that BM is the angle bisector of angle PBA. Okay, so we can break this down to beta. Okay. Now we have that this angle here is going to be equal to this angle. Angles subtended by the same chord in a circle. So this is going to be alpha, and this will be 2 alpha. Okay. In a similar fashion, this angle here is going to be equal to this angle. Angle subtended by the chord AM. So this will be beta, and this will be 2 beta. So we split it. Okay. Now, since APNB is cyclic, this implies that angle PNC is equal to angle PAB, which is equal to 2 alpha. So this angle here is going to be 2 alpha. Okay. And in a similar fashion, we get that angle PND rather, is equal to angle PBA, which is equal to 2 beta. Okay. So it means this angle here is 2 beta. Okay. So what do we have? Now we want to talk about the angle bisectors. That's the angle bisector here and the angle bisector here. Now I'll erase some angles that we've already used and we won't use again. So let's just have what we want now. Now, looking at this triangle, have that this is an isosceles triangle. So triangle CPN is isosceles. Okay. And now we're talking of the angle bisector of PCB. So now, since the question talking about the angle bisector of PCB, the angle bisector of PCB is also the angle bisector of angle PCN in this isosceles triangle. So it means it's going to be the perpendicular bisector of PN. Okay. So take note of that. It's the perpendicular bisector of PN. And in a similar vein, the angle bisector of ADP from the question is also the angle bisector of MDP in this isosceles triangle, because this is also isosceles because this angle here is 2 beta, this angle here is 2 beta. Okay. So it means it's going to be the perpendicular bisector of this segment MP. Okay. Now, in a circle, how can we get the center of a circle? Any two, the center of a circle lies on the perpendicular bisector of any chord, yes, that same circle. Okay, so it means the intersection point of the two angle bisectors given by the question will intersect in the center of the circle ABP. Okay, so it will pass through the center of the circle ABP. Now, from the converse of this theorem, if we have a random chord in this circle, the perpendicular bisector of that chord passes through the center. And so, since AB is a chord in this circle, so look at the circle we're talking about, A, B, N, P, M. So AB is a chord. So it means AB, the perpendicular bisector of this chord, passes through the intersection of the other two angle bisectors. So in fact, we have that O is the center of the circle, and any chord you pick, even if it's AM, so we have all the perpendicular bisectors of all the chords passing through the circle, and that's it. We have the problem solved. So I think it was a pretty interesting problem, and I mean there are other things you can explore from the problem. As you can see from my diagram, I brought in the tangent. That was the first way I solved it initially, but so you can explore the problem on your own and share whatever findings you have in the comment section. So I'll just do a brush through of what we did. So we brought in points N and point M. And what were these points? These points, we defined them as the intersection point of the circle and the sides of the quadrilateral. And then what did we prove? We proved that this AN is the angle bisector of PAB, and a similar thing here. Okay, and then what else did we do? We got that these two angles are equal, and this is an isosceles triangle. Okay, and also we got that this is also an isosceles triangle by angle chasing. And since the problem asked us, problem dealt with the angle bisector of ADP and PCB, and in fact, since they are both angles in isosceles triangles, we can redefine those angle bisectors as the perpendicular bisectors of the bases of those isosceles triangles. And luckily for us, those bases happen to be chords in a circle of interest. And in fact, we got the center of the circle, and we got that the perpendicular bisector of the segment AB passes through the center of the circle because AB is a chord in the circle. So that's it, guys. And I think it was a pretty nice problem. So share what you think, and probably we'll discuss other problems from this year's IMO. Okay, so that'll be all for now. Do have a wonderful day and keep on solving maths. Yeah, goodbye.